Hello, my dear students. Good evening, everyone. I'm fine, Dipin. Thank you for asking. Good evening. Good evening.
Good evening,
Arfan.
sir.
Good evening. Good evening, Dipin. Just wait a few seconds and then we will start the session. I'm fine. Thank you for asking. Hello, Shreyasi. Rayan. Good evening. Good evening. Good evening, Shruti. Abdullah. Zunaira. Nakia. Good evening, everyone. Good evening. I'm fine. I'm fine. Thank you for asking, Abdullah. So I hope all of you have tried the numericals related to the equilibrium which we discussed in the last class. How many of you try those one? Hello Rida, Nakia, okay, Abdullah, Dipin. What about Shreyasi, Ryan, Neha, Akhil, you tried or not?
I didn't get the time to, so I've been sleeping.
Okay, so please try that. Try to find some time. Okay, okay, Neha. So I request to all of you every time whenever discuss we anything, I request to all of you any kind of variety of it. Please don't forget to find some time to practice it out. Okay, every day is important for us because after few days, after 1 month, you will not get that much of enough time to cover the backlog. Right now, if you are going to cover daily basis, then if anything which is not clear to you, you will immediately in the next class, you will ask me, sir, I am facing this difficulty in this one, like that. But after 1 month, we try to cover that one, then definitely we will not get that much of time because we have already covered the so much of syllabus. Yes, Shweta, ma'am. Yes, Shweta, ma'am. Good evening, Ariba, Akhil, Nakia. Good evening. Good evening. Good evening. Good evening. Shweta, did you have any kind of doubt? Because our batch manager name is also Shweta. Ma'am. Just that's why I get confused on that one. Yes. Good evening. Good evening. Felicia, Ada, Mohammad Faizan, Aaron, Ibrahim, Ananya,
Good
Soumya.
evening, sir.
Good evening. Good evening.
Good evening, sir.
Good evening. Tristan, Shivani, Ryan. Yes. Yeah. Okay. Shweta ma'am is our batch manager, not a student. Because I get confused that I think though two students have a, and I think all of you also know that who is your batch manager, right? So any kind of issue you
Yes,
face,
sir.
you are directly going to reach out to the Shweta ma'am, right, my dear students? And I can see many students did not turn on their camera. I request to all of you, please turn on your camera. Aaron, Mohammad Faizan, Ada, Kritish, Shruti, Abdullah, Zunaira, Akia, Reda. Please, my dear student, please don't make me to call your names. Please do it. Shivani, Ryan, Ananya, please turn on your camera, my dear students. We have to, without saying, we have to do this kind of activity. Okay. Hello, Andy. How are you? Okay, your mic is not working, I think. Hello, Sana, Hari, Aditi, Suryadev, Sabreen. Okay, my dear friends, so good evening everyone and welcome to the PW Gulf. In today's class, we are going to continue our discussion, but with the medium. In the last class, we have finished out our discussion on the equilibrium. In the last class, we finished out our discussion on the equilibrium and we have said if we take a same kind of charge, positive, positive or a negative, negative, so you have to put the third charge in between that, in between both the charge. Either it's a negative or a positive. Either it's a negative or a positive. When the two fixed charge having a same nature. So always third charge can be any kind of nature, either it can be positive, negative, always you are going to put it in the middle of it. But what about if the nature is not same? So we have discussed if the nature is not same, in this scenario we cannot put the third charge in between that. Whatever kind of charge it is, it's a positive or negative, we can never put the third charge in between that, because we already discussed we draw the direction of the forces so that you get an idea, right? And we need to put the charge outside of it, and the third knot we put it out there to put the third charge near to the smaller charge, outside of it near to the smaller charge, right? Okay, now coming to the third thing, in the third kind of scenario, they will ask you what will be the magnitude of the third charge, and what will be the nature of the third charge, and the position of the third charge. Position we can easily find it out by putting it near outside of it near to the smaller charge. By that we can easily find out the position of the third charge. But when you're talking about the magnitude and the nature, to find out the nature, we take out the nearby charge. If it's a smaller charge, we take the smaller charge, one of the two fixed charges, and we will check it's in the equilibrium or not. If it's not in equilibrium, then third charge nature will be different one. We need to choose another one. And to find out the magnitude, we will take a second charge, forces on the second charge, and by that we can equilibrate that one. Okay, I hope you have go through that one. I'm just giving a recap. Without solving it by yourself, you will not get that much of clarity. Okay, if you are doing it, then it's a very wonderful thing, and I'm pretty sure that nobody is going to stop you to achieve your target goals. Sir, what is fixed charge? What if different nature? Then where will we put the third charge? One of the student is saying, sir, what if the third charge having these two charges like a plus q minus q, the magnitude is same. This kind of situation will not come, my dear students. Okay, this situation will not come. They always going to mention you that kind of scenario. By that you can easily find it out. Okay, so I request to all of you, those who didn't try those equilibrium questions, please after the class try those ones. It's really important to all of you. Whenever we discuss any numerical, any type of variety of numerical, it's really important to all of you to practice. First you need to practice. By practice you will understand how much it is clear, how much it is not. When the doubt get clear on that one, then you need to practice it again and again, again and again. Master that thing. If similar kind of numerical come, if tiny value change, I can easily solve it like that. Okay, so you have to revise in such manner. If tomorrow someone will ask me the similar kind of question, I will be easily solve that one. So I request to all of you, my dear students, everything you are doing is good, but one thing we need to add is what? Revising. Revising in such manner that you will master that thing. Because when we are going to cover lots of things and we are thinking that when some holiday will come, some day school off will come, I will cover it. So that thing that day will not come. Okay, so I request to all of you, right now syllabus is small. Tomorrow, in tomorrow's class, we only cover the three kinds of variety, means three numericals. In short, two numericals if I am going to count. 2-3 numericals, you need to cover it properly, okay, in a master manner. Every day you will get only this kind of 2, 3, 4, 5 questions. So daily, at least you have to cover this one. If you are not able to attempt the DPP, at least cover the questions which we are discussing in the class. These are really important, okay? Because by these examples and question, you will get a deep knowledge on the concept. Now, my dear friends, in today's class, we are going to talk about the dielectric. So many students are asking, sir, what if we put the charge into medium? And okay, Sabri, what if we put the charge in medium, and when we were applying the Coulomb's formula and we discussed the one of the point was the force magnitude will change if we change the medium, and over there we denoted the sign epsilon r, which is a relative permittivity, and at that time we have said that relative permittivity value will be given in the question. That value will be given in the question. Then after that we are going to talking about the electric field. Very tiny discussion we will do, and then motion of charged particle. If we are able to finish all these things, then charged particle in electric field. If you are able to finish this out, then in the next class we will discuss the finding out the electric field because of the continuous bodies, and that part is really important, not tough one, because I already gave you the background in the bridge course. So whatever we have covered in the bridge course, the continuous bodies, finding out the moment of inertia of a continuous bodies, like a charge density, limit, taking an element, those three things are going to be used again. Only the in the next test, only the amount of syllabus we are going to cover before the 2 days of the test, only that that syllabus will come, those topics will come. Okay.
So, sir, for this test, right, as it's subjective, just the NCERT cut is enough, right?
Yeah, NCERT also, the notes also, the topics just like a vector form of electric field form, Coulomb's form. Yes, Vijay.
So textbook question answers, examples, if you're doing that, for now it's enough?
Yes.
Okay.
Yeah. Okay, Saida.
Sir,
Yes, Vijay.
sir, like today only I joined. Can you just explain what you did total now?
What is total of?
I mean, I just want to ask, like, what did you teach till now? Like, I just only joined today.
Yes, well, I was also wondering that I was seeing your name first time. So thank you for informing me also. This before starting that one, we will cover the some of the things, so everyone will get the idea. Also, you will get that idea. Don't worry about it. And thank you for telling me. So I will move on in such manner. Now, my dear friend, just like you know the Coulomb's formula, which is what Q1, Q2. If two positive charge is there, right, they will repel each other. If two negative charges there, they are going to repel each other. But the unlike charges are going to attract each other. So Coulomb said, according to the Coulomb's law, if you want to find out the magnitude of that force, your force formula should be K equal to Q1 Q2 upon R square. And K value is what? 1 upon 4 pi epsilon naught. K is constant. K is constant, but this K is for the vacuum when there is no medium. When there is a medium, right? What if we put these charges into the medium? Okay. Vijay, I think you already know this formula.
Yes, sir.
Okay. Now, what if I put this into a medium? What if I put this into a medium? If I put it into the medium, then I told you, you're just going to do what? Our force will be K Q1 Q2 upon R square, the distance between the both charges, into 1 upon epsilon R. You're just going to divide it by the epsilon R, which is a relative permittivity, When the both charges are in medium, we just going to divide the force with the relative permittivity. By that, you can easily find out the how much amount of force they are going to apply on each other. This was the basic thing when the both charge in medium. But now there is another catch in this kind of variety. What is that? What if both charges are not in medium, but in between that there is a medium? In between there is a medium. My dear students, many of you have used the telescope, binoculars, like many of you have used magnifier glass also you have used. So that magnifier glass is what? Medium. Your eye is in the air and that object is also in the air, but still you can see that in a magnified manner, that object in a magnified manner. In the telescope you can see near to you, the distance can be decreased and increased by the setting of that glass. Am I correct or not? So that glass is what? A medium. So because of that medium, the distance between the object and the observer get changed. Yeah? And the visual experience also change. Am I correct or not? Same way, if we are talking about, my dear students, if we are talking about both charges are in the same medium, but in between that there is what? There is some medium. Please pay attention on this one. Like this. These two charges here, you can see Q1 and Q2, both are in the same medium, but there is a medium in between that. Total distance between the both charge is B and the thickness of that medium is T. Thickness of that medium is T. Now this time force is going to change or not? What will be the force? If it is going to change, then what will be the force? This is another kind of variety in the medium. General question can easily solve it by like this. In your school, you will see the medium and you will write down divided by the relative permittivity. You can easily find out the force when the both charge in the medium, and this is a very easy one. It's not a big kind of thing. Both charge. Yes, Vijay.
Sir, like why are we dividing it by relative permittivity?
Relative permittivity. Now you can see, I think all of you have passed the 10th class. All of you, and I'm assuming that Vijay also passed the 10th class. My dear students, how many of you experienced that phenomena? A bucket filled with the water and in a swimming pool filled with the water, and you have seen, if I throw some object and the object at the bottom of it, and if I put a rod inside of it, like this, but I am able to see it like this, little bit bend up. We arrange the originally rod is like this, but we are seeing the rod like this. Originally coin or an object at the bottom of the swimming pool, but we are experiencing that it's little bit above from the bottom of it. So it will feel like your distance get reduced. Your distance get reduced. And if you are going to, yes, Arfan, if you are going to run on a flat road, you can run with your full efficiency. If you are going to run on a flat road, you can run with your full efficiency. But if I ask you to run in a water, on a beach, and a muddy kind of beach. So you cannot run on with your full efficiency. Am I correct or not? Your efficiency output get decreased. Your efficiency not change, but the output of that efficiency get decreased because of the physical phenomena. Am I correct or not? Same way, yes, if you are going to put these two charges into medium, the effect of this electric field is going to change, which is going to decrease. Because, my dear students, I'm not going to go in that detail, but you can imagine if there is a medium, some molecules also will be there. Tiny molecules will be there or not. And those molecules are made of what? Dipoles. If you know, if you learn the enough amount of chemistry. And those dipoles also consuming the charge. So that is going to affect the magnitude of that force, and which is going to decrease. So that's why we are dividing it. Is it clear or not?
Yes, sir.
So
There is a mathematical proof also there, but which is not part of our discussion, because if we are going to discuss that, that require also extra knowledge, which is up to the level of MSc of physics. But I'm trying to convince you with the logic. Okay, it's not a physical mathematical way derivation kind of thing. I'm trying to convince you with the logic, and I hope we have done. I hope all of you get clear with that examples. Huh?
yes, sir, yeah.
Okay. Okay, very good, my dear students. So, my dear students, this scenario we can easily understand, and we just need to divide it by the relative permittivity. By that we can get the force, and it's a very easy one. But what if we are talking about the second scenario? So what we are going to do in this one, because the charge is not entirely into it. Some of the electric field will go like this. Some of the electric field will pass through this. So how we are going to define or the force between them? So over here we are going to consider a assumption. Please pay attention on these two situations. There are two charges, one in the vacuum, distance V vacuum, distance in vacuum, distance in medium. These two charges in medium. Suppose like, and you see, if I'm going to talk about the force because of this one, it will be K Q1 Q2 upon dV square. And if I'm going to talk about this one, F equal to K Q1 Q2 dm distance and the 1 upon epsilon r, which I told you. Now we are assuming to get our result, okay? Both force are equal. So K Q1 Q2 upon dV square equal to K Q1 Q2 upon dm square into epsilon r. Everything get cancel out and you will get what? Dm square epsilon r will be equal to dV square. Huh?
So
Hmm.
here we are just assuming that their forces are equal, right? Like they're not actually equal, right?
We are assuming it to create another kind of scenario so we can find out what will be the effective distance. Effective distance is what? The distance which is actually we are going to use, which means like suppose like effort is too much but output is less. Effort is too much but output is less. So effective efforts, like effective efforts, the efforts which was like we are studying for a 1 hour. In the 1 hour, we only pay attention or our concentration only for the 40 minutes. Rest of the 20 minutes, our thoughts go somewhere else. Effective learning. Okay. Is it clear? That thing is go waste, na? So there are some unnecessary thing which we are going to consider. One of the major thing is what? Distance. So over here, we are going to consider effective distance. Now we are assuming it to get a result. The one of the student is saying, like Mikat is saying, sir, you assuming it, but in actually they are different because it's a medium. Obviously, you are correct. Okay, that's why we use the word assuming to get a one result. Yes, to get a one result. Now, when I simplify this, you will say what? dV will be equal to dm into root epsilon r. It means this distance, these two forces only can be equal if this dV will be equal to the dm into root of epsilon r. Am I correct or not, my dear students? Huh?
Yes, sir.
Yes, sir.
Okay. This dV, these forces can be equal to each other only in which situation? When the distance in the vacuum will be equal to the root of relative permittivity into the, we take the root on both sides to remove the square. Okay, Arfan? So when we take the root, square get cancelled out, it become root epsilon r. So my dear students, we just created a situation where, at which situation they are will be equal. Please write this down, then we will solve, we will get the result. We will discuss that question. Okay, that part, this one. How to write down the force in this situation. Okay, some other situation is also there. By that you will understand how to implement this one, which is a effective distance. Clear? Yes, Vijay, any kind of concern, any doubt? Arfan, Saida, anyone?
Sir, so if both forces are equal and only if dV is equal to dm root of.
Yes, only in this situation. We are assuming it to get a one another results. By that we can find out the effective distance.
So, sir, our question was that if a different what you call medium is there in between both the charges, then you have to know electric distance, right? This
Okay.
is the answer.
Yes, this is the distance you are going to use when both charges are in a different medium. Please pay attention. Let me give you one another kind of overview on this one. These two charges are there and this is the distance. Okay, now please try to understand in a reverse manner. Two charges and this is the distance. Two charges, this is the distance, but in the medium. Right? Now we set a condition, what if these forces are equal to each other? So what is the factor that is creating a difference? What is the factor that is creating a difference in between these two forces? Only the medium. And because of the medium, that distance between the charges, the path this electric field is going to cover is going to change. Maybe you can consider this because of the some medium, the path of the electric field get little bit lengthy, So if their forces are equal, what is the main factor that is going to be a differentiator? This is the situation when there is no medium. There is a situation when it is a medium. So if the force is equal, so what is the differentiator? That distance and the relative permittivity. Right? And in the previous scenario, what we have seen? Charge in the vacuum, but there is a medium in between that. So we are trying to merge both the scenario. By merging them, and we try to get a result where we can define the effective distance, because only this is the changing factor, this distance and the relative permittivity. Okay, now let's discuss. I hope all of you have write it down, because when we are going to solve it, you will get a more clarity. Okay, now please pay attention. Now this time they are saying this is the both the charges, this is the d distance between them, and t is the thickness of it. Now write down the effective distance. In this scenario, write down the effective distance. So total distance is what?
D.
Because of this medium, distance is going to change. Distance is going to change only in which part? Only in this part, because medium is only in this part, not the entire part. Is it clear or not? So this distance is going to be countable. Huh?
Yes, sir.
Medium is only in this part. So only in this part we need to find out the effective distance, not in the other parts. Is it clear or not? Huh? So
Yes, sir.
effective distance, when I'm going to write it down, will be equal to what? D minus T. Now please pay attention why I'm writing minus T. Because if I'm trying to write down the effective distance of that medium, then I cannot conclude two values. You can see T is the physical length, but according to the electric field and the force, that is not the distance. We need to find out that effective distance. And we said what? The effective distance will be root epsilon r. This is the medium length. Is it clear or not? So medium length is what? T, and relative permittivity root r. So if I consider the length of the medium T into root epsilon r, then why I'm concluding again T? I need to remove it. I need to remove it now. Is it clear or not, my dear students?
Yes, sir.
Yes, sir.
That's why we subtract it from in this length, from the total length. Total length is D. Now again length is going to increase because of that medium. Just like I told you in that figure, this is the straight road and this is a bended road. So which length is which road length is bigger? This A road or this bend one? Whichever bigger length.
B.
Obviously B1. So when we are going to put the medium, the length is going to increase or decrease?
Increase.
Increase. So that is the thing we are doing now. We are adding one extra length which is plus T into root epsilon r. And we already concluded the medium length. So why we are going to do it again? So that's why we are subtracting it. Is it clear or not?
Yes, sir.
Sir, can you tell once again why did we take D minus T?
My dear students, the total air distance is what? D minus T. The distance, this distance and sum of this distance will be what? X and Y. So X plus Y is what? D minus T. Huh?
Yes, sir.
Because this is the air. So air distance, we will write it down as it easily. Right? In medium, we have to write it down the effective distance. So this, I assume that if it's a X, if it's a Y, so sum of the X and Y is what? D minus T. So I put the D minus T. Now I put the medium length, which is what? Medium distance multiplied by root of relative permittivity. Is it clear or not?
Okay, so effective distance will be the distance in R and the distance in medium.
R and AM. Can you please repeat again? Yes, Deepan, just a second.
So, sir, the effective distance will be the distance in air and the distance in medium.
Yes, total distance, we are going to count that one. Okay,
Okay, sir.
sometime they also consider only this one as the effective distance for an individual one. But for the total one, we are going to use overall one. Okay, because it's in the entire medium. Yes, Deepan.
Sir, D minus T represents the distance in vacuum, right? D
Yes,
minus.
yes.
So T into root of epsilon r is also dV only, right?
No, it's in this length of the medium. Because I told you na, which road have a bigger length, so all of you give the reply B. So the distance get increased, right? Because this
Sir,
medium.
but dV equals to dm into dV equals to dm into root of epsilon r. So didn't we put the equation for dV here?
Only in this scenario. Only in this scenario when medium is there, both charge in medium. Only in this scenario you can write it down. But in this scenario, what is happening? Some part of both the charges in medium and in between, in vacuum, but some part of is there which is have a medium, which is thickness T. So in that scenario, we need to conclude the air distance also and the medium distance also. So for the only for the medium distance, we are saying what will be the effective distance in this medium. If I am going to conclude the entire one, then we have to write it down entire D minus C. Maybe you are confusing, like if, please try to understand, if both charge in medium, then this is your effective distance. Okay. If partially in the medium, then this will be our effective distance. This thing is clear or not?
Sir,
Yes.
no, I had a doubt that T root epsilon r will be equal to D only, right?
Equal to effective,
D, because D,
equal to the medium length. Equal to the medium length.
yeah,
This
medium length is T, right?
medium length is T, but this medium is how much this medium is going to affect on the or we can say strength of the electric field. That's how we
T
need to
root
define
epsilon
it.
is strength of medium.
Huh?
T root epsilon is equal to strength of medium.
No. You are taking wrong statement. I'm saying this medium is defining the strength of the electric field in that medium. My dear friends, this is a medium. Okay. This is a medium. Just like I gave you the example of this one. Please try to understand this one. This is the road and water is filled up to this level. So this length and this length, you are going to count as it easily. Yeah. You are not saying like this. Till this one, this is your actual road, and because of refraction, the road seems like bend one, right? In previous diagram, we made it bend from the top one. That is not correct. Okay, please pay attention on this one. Only in that part, the part which is into the water, only that part will get bent, right? So this pound, the total length, this part is going to be considered as it is now. Am I correct or not? The part which always remains same, it is not going to change na, because it's not in the medium. This part of the road, that length is not going to change na. Huh? Surya
Yes,
Dev.
sir.
Okay.
Yes, sir.
Only this part will get affected by the medium. So if I'm going to conclude the entire thing, so you are going to count this length also, and the effective means the part of the road which is get affected by the medium. So you are going to consider this part which is in medium, and you are going to consider that part which is outside of the medium, because you are counting the entire road. Same way over here, if you are counting the entire system Q1 and Q2, then you have to count the distance, total distance, the distance in air and the distance in medium. So you are counting the distance which is in medium, which is what? D minus 2, and the distance in medium, which you've already get the formula for that one, is medium distance into root of relative permittivity. Is it clear or not?
Okay, sir.
Clear? Anyone have any other concern? Vijay, Nitya, Muhammad Ahil, Zoha, Samiha, anyone?
Sir, like, so when do we use dv equal to dm root of r separately? I mean, only that.
Separate level when the both charge in
Basically.
completely in medium.
Okay.
Now, so this is our distance. Now the force formula will be F equal to K Q1 Q2 upon D minus T. Let me write it down. R whole square. Is it? Are we just substituting T? Yes, yes, Abdullah Ali. Yes, Abdullah Ali. Absolutely correct. It's a very basic thing. Do not create unnecessary kind of hype on this one, because from this part only this level of question will come. Next, another level of question I add up in the slide in the next one. So obviously, automatically you will get clarity on that one. Okay. So many kind of variety can be created, but we are only going to discuss which is going to be useful for us. Okay. And this kind of thing also you didn't see in your NCERT, this variety. So just try to understand this length, just like I gave you the example of the road. Okay. Now you have seen only one medium is there, only one medium. Okay. Now you are going to consider the two medium in the next one. When you're done with the writing, please tell me so we can move on to the next one. Done with the writing?
Yes, sir.
So,
Only one. This kind of situation, Dipin, this kind of situation will not come, like this charge in medium and this is in not. Okay. So this kind of situation will not come in your syllabus.
Okay, sir.
Okay. Now coming to the next one. Now please try and tell me the effective distance of this one. Do it fast. Do it fast. What can be the distance from this one? Total distance is D. You can see still there is a space over here. They are not entirely into that medium. Okay. So don't get confused by the situation. It's a very easy one. You just need to apply the formula. First is what? D. And so this round space, this length and this length, sum of this length in air will be what? T1 plus T2.
T1.
yes, sir.
So this is the length of this tiny vacuum. Very good. Saida Joya, absolutely correct. Abdullah Ali also. Very good. You also correct. I think by mistake they put the wrong bracket. Okay, no issue. Then T2. Then add the medium. Is it clear or not? Zoya, okay.
Yes, sir.
Okay. Clear, my dear students?
So,
Any
Yes, sir.
easy na? Now you can easily apply this formula, this condition.
yes.
Okay. Now you can easily put down the formula F equal to K Q1 Q2 upon only this distance D. You can also write like to show the bracket only D minus T1 minus T2 plus T1 epsilon 1 plus T2 epsilon 2 whole square. Okay, I just open the bracket so both the T1 T2 become negative. Easy na? Now you just need to put the value of the thickness of the both medium and both relative permittivity. By that you can easily get the answer. Do not think that any extraordinary kind of question will come out. Only up to this level question will come into the JEE Mains till the level of JEE Mains NEET level. I'm not talking about the advanced level. Okay. So this question, this topic is also for the competitive one, for the entrance exam, not for the board. Okay. During the discussion of any topic, I will give you the idea about it. You have to prepare it accordingly. Anyone have any kind of confusion how to write down the effective distance? Anyone have any confusion in this one?
No, sir.
Very good. Okay. Kritish, where are you? Vijay, is it clear? Yes, Mikat.
Sir, can you move?
Can I move? Okay. Yes, Vijay, is it clear?
Yes, sir.
Okay. Now we are going to talk about our another topic, which is electric field.
Sir,
Hmm.
after the last step, right, I did, okay, nothing. I did square root. So will the like answer become wrong in order to remove the square?
You open this square.
Yeah.
You don't need to because it will lengthy your calculation. Because if you do the subtraction and addition within the bracket, then final result will come less, and you can easily square that up. So don't do this activity when you solve this one. Okay. Now, my dear friends, the thing is what? Now we are going to discuss the electric field. Just like you cover the portion of the gravitational field. There is a region around a mass. When the another mass come into that region, it will experience a force. That is called gravitational field. Same way, there is a region of a electric field. There is a region. If another charge come into that region, it will experience a force. Like in a magnet. There is a bar magnet. And in that bar magnet, there is a region around it. There is a region around it. And when anything come, magnetic material within that region, it will experience a magnetic force. That is called magnetic field. So, my dear friends, around a charge, there is a field. Around a charge, there is a field. When we put a charge near to it or any charge come into that region, it will experience a force. So, that region will be considered as a electric field. So, to measure the strength of the electric field, we done one experiment. We put a test charge into that region. We put a test charge into that region because the test charge magnitude is very less as compared to this charge. This test charge magnitude is very less, approximately negligible. Is it clear? Just like you throw a stone into a solar space somehow anyway, So it is not going to affect any other planet into the solar, in the space. That tiny particle is not going to affect the solar system, right? Same way this charge have a magnitude according that one, very small one, so it is not going to affect the process of this one. Is it clear?
Yes, sir.
Okay. So to find out the strength of this electric field, strength of this charge, electric field, we get a formula. Force on a charge, yes, very good, Abdullah Ali. Force divided by per unit charge Q naught, test charge. So in that one, what you get? Equal to K, force formula is what? K Q1 Q naught K Q naught upon the distance between B R square upon Q naught. So your electric field will be KQ upon R square. KQ upon R square. And now my dear students, you can see Q is Coulomb. So what I am going to write it down? And the R square meter square.
Sir,
Hmm.
can you explain the writing part again? Like, what did you write?
Over here, we are saying to measure the strength of a charge electric field, we done a one experiment. What we have done, we put a test charge into that region that is not going to affect the any kind of physical scenario of this charge, because that, just like I gave you the example, when a tiny stone, if we put it into the space, it is not going to affect the any kind of motion of any kind of planet, right? Because it's a very small one. Same way, it's a very small one as compared to that one. So what we have done to find out the strength formula of the charge is what? We are saying this charge is going to experience a force because of this one, right? We are going to get the force on this one because of this charge. So this charge come into that region, and that region is what? Electric field. That region is what? Electric field. Now, my dear students, how we can define this formula? Equal to force upon test charge. Force per unit charge means this force per unit charge, this per unit charge, like you already know. Like, let me give you an example which you already know. If you buy the 73 bananas, or we can say in 73 rupees, you can buy 18 banana. Too costly. So in 1 rupee, how many bananas you can write it down? 18 by 73. Huh? So this will give you what? Per unit rupees. This is the your 1 rupees efficiency, your 1 rupees value. In that value, you can buy that amount of banana. Same way, we are denoting what? Force per unit charge. Force per unit charge. How much amount of force this charge is going to experience? How much amount of force this charge is going to experience? That is denoting what? Strength. Strength of a this charge. Strength of a this rupee. This is a logic. It's a logic. There is no big science behind it. Everything is not big science. This is simple banana sabji mandi. Simple sabji mandi logic. Is it clear or not?
Yes,
So,
sir.
unnecessarily, we
Yes,
don't
sir.
need to create a hype of a tiny thing. You need to trust your teacher. Is it clear or not?
Yes, sir.
I already mentioned that many of my students get the rank, 2-digit rank. I didn't get that much of a possibility to get a 1 rank by my students. Only that amount of, only 2-digit rank. One day, one of my students also will get the 1-digit rank. You need to trust your teacher, okay? So this is just a sabzi mandi logic, that force on a per unit charge, that is the efficiency, that is the strength of this charge, and this is the strength of this 1 rupee. Just like Iran currency is collapsing, like Gulf currency is collapsing, like that. Okay, clear?
Yes, sir.
Okay. Yes, Vijay. I think
Sir, so Q is the force experienced by the test charge by the source charge. Yeah?
yes. So that efficiency denoting it. So that in short, we are saying what? This is the strength of this 1 rupee. By this 1 rupee, you can buy this amount of banana. This is the strength, this F upon Q naught strength of this charge. Clear? Yeah, banana is my
Sir,
friend.
sir,
yes, yes,
that
please.
C by M square, how it came? C by M square.
Okay, I forget to put the K unit value. That kind of thing happen when we engage too much over there. Okay. So just like force is what? Newton per Coulomb. Okay, you can put it like this. Sometime we made a mistake during that heated debate, heated explanation. I hope nobody get offended by this banana. Okay, because when I was in a IT sector in Hyderabad, so I was only eating the banana because it was the cheapest one. Other fruits I cannot afford at that time. Banana is the cheapest one. So many banana you can get in a few rupees. Yeah, this one is costly because of the war time. Okay, we can move on, my dear students.
Yes, sir.
Okay.
Yes, sir.
So what are the unit base C by M square for E equal to K cube as
That was my mistake. Okay, that was my mistake. I already mentioned it. Don't make me. Okay. Now you can see, my dear students, the formula we get it is what? E equal to KQ upon R square. Okay. If we are not, if obviously during that charge magnitude is not going to change, but if you are moving away from the charge, if you are going to move away from the charge, so this distance is going to increase. If this distance is going to increase, the electric field is going to decrease. Huh? Am I correct or not?
Yes, sir.
Yes, sir.
EF means electric field is going to decrease. So if you need to draw the graph will be, initially it's a maximum, then if you go away it is going to decrease because it's a square, so parabolic one. Clear? Vertical
So Q constant.
yes, K is constant, Q is that's why it's a constant, because we are denoting only the relation between the electric field and distance. If you move away from that source, the electric field is going to decrease, because we are only denoting the relation between the electric field and the distance, not between the electric field and charge or charge and distance.
Okay.
Vertical axis denoting the electric field, horizontal will denote the distance. When a such kind of topic comes which required a extra attention, I will indicate you. I will not leave you like that one. But when simple thing come, consider this as a simple, okay, only this amount. Syllabus, they design the syllabus like this. Okay, just like you have covered the mechanical properties of solid in your 11th class. There is a two different book in your engineering, and a very detailed one. When you are going to learn that book, by your own. Maybe some of the thing you will not understand. Only can be covered by your professor. Yes, Sajida. Yes, Joya.
No, sir, just previous slide. Can you go for the second one? I think I missed the point.
Okay. Can we move on, my dear students? I think we can move on.
Yes.
Okay, let's do a little bit fun activity, okay, to make a moment lighter. Yes, my dear students.
Okay, sir. Thank you, sir.
Okay. My dear students, if I ask you what will be the dimensional formula of the electric field, first you need to tell me what will be the dimension formula of the charge. Huh?
Charge is A.
Charge, dimension formula of the charge.
AT.
AT. That's why I write it down, na? T is time, A is the ampere, right? What is the dimension formula of the force?
MLT.
MLT minus
M L
MLT
T minus 2. So your dimension formula will be M L T minus 3
A minus 1.
A minus 1. Only by the unit you will write down the dimension formula. Very easy way to do it. But my dear students, dimension formula can be asked from anywhere. Okay, so do not consider that this is a unit and dimension chapter, so only from this one. Somehow, any kind of formula which we are going to cover, they can ask from any one of them. Okay, examiner have a right to make it tough within the syllabus. Okay, he will use some tricks to do that. He can also ask you what will be the K dimension formula. Okay, so I hope you know that one, how to do that. Just like we find out the unit of the K. Yes, can anyone tell me what was the unit of K?
Unit meters per
Sir,
second.
QC.
Meters per Coulomb square.
Very good.
Meters per Coulomb.
Very good. Very good. Absolutely correct. Newton meter square. So F into R square upon Q1 Q2. Force Newton meter square, two charges Coulomb square. So now you can easily write down the dimension formula. Right? That's why.
Yes.
Okay, now moving to the next thing. My dear friends, just like we have said, we get the formula of the Coulomb's law, finding out the force F equal to K Q1 Q2 upon R square. And in that formula, there was a limitation that we can find out the force only between the two charges. Only between the two charges. What if there multiple charges was there? So we said we can use a superposition principle. By that, we are going to make a pair of the two charges and we are going to add them vectorally. This is the thing we have done. Am I correct or not? In a square, we put the charge on a square. We are going to vectorally add all the forces. Same way, over here, we are going to vectorally add the electric field. Suppose there are multiple charges Q1, Q2, Q3 on a different point, but they are asking us what will be the net electric field at this point. What will be the net electric field at this point? So you are going to find out the electric field by the each charges at that particular point, and you are going to do what? Vectorally, you are going to add them. I'm saying vectorally, because along with the direction you are going to add them, not just a magnitude. Is it clear or not, my dear students?
Yes, sir.
Yes, sir.
Okay. Easy na? You already covered this one, so that's why it's like an easy one. We can vectorally add them. What we have done over there in the square question, we take the component,
Yeah.
we take the component. Okay. Now, one basic logic I need to tell you again, even though I already mentioned, what will be the electric field direction from the positive charge? Away from the source.
Away
Okay.
from the charge.
Yes, it will feel like it's originating from the source. Away from the source. Radially outward. For direction of a positive charge is radially outward. Direction of a positive charge is radially outward, and direction of a negative charge radially inward.
Inward.
Yes,
Inward.
it looks like the electric field lines are terminating into the negative charge. Electric field lines are terminating into the negative charge.
Sir, is positive and negative is for the point charge, right?
These point charges plus q1 minus q1 plus qn, same magnitude but different nature. So it's only for the just a simple diagram, no sense behind choosing which one is positive, which one is negative.
So how do we know the direction of the electric field?
This is the direction. So if there is a positive charge they are using, so it will be away from the positive charge. Let me show you in the next slide. Yes.
Sir, like why you're how you're telling that like the charge is outwards if it's positive charge and negative like that? How you're telling that?
Experimental, by the Millikan drop experiment. So by that experiment they get that idea of the direction. Okay. So by the experiments they get that idea, okay, in the positive charge it will get away from in this direction and away towards this direction. Okay. By the, it's a experimental result. Okay. Now,
Okay.
suppose like this is a positive charge and they need to find out a electric field at this point. So it's a positive charge radially outward, so away from it. So in this direction, away. If I choose the negative charge, if I make this negative charge, so what will be the electric field at this point? Towards the charge. Is it clear? And the distance always be line of joining. Is it clear or not, my dear students?
Yes, sir.
Yes, sir.
Yes, sir.
Now I think all of you will be able to define the direction of the electric field at any point because of a charge. Easy na? Away, 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 going away, going away. Any point you are going to choose, going away, towards. So it will always be towards the charge. It will, the arrowhead towards the charge. Yes.
Sir, could you go to the last slide? Sir, the point in the center where the electric field is originating from, that's also a charge, right?
No, no, it's not a charge. It's just a point.
Okay.
Need to find net electric field. Now the questions related to this electric field, so many questions we are going to discuss in the booster class. I hope you are not going to mind that one. Okay. Some basic one I will discuss it over here, and some other variety related to this one we will discuss in the booster class. So please do not miss out the booster class. I'm giving you a heads up. Okay, whatever the thing we are going to do in the booster class, so that you are not going to miss that out. Okay, I can easily skip out this out. In this chapter, the amount of question you are going to practice, that this chapter will become more stronger, and that lead will give you a benefit in the other chapters. So even though you are not covering theory part that much, but cover the numerical part. That is the most important thing. Okay, without numerical, there is nothing in this one. So every time, please find out some time to practice those numericals. Okay, please do not think like that you can skip the numerical. Okay, now let's take this one. Two particles having a charge q placed on the two vertices of a equilateral triangle. This is your equilateral triangle. At any place you can put the two charges, and they are saying edge length is a. Find out the magnitude of an electric field on the third vertex. So you can choose any one of. I always choose this corner to find out the net one. Okay, so what it will give me the visual advantage, because we started learning from this side. We always see the figure like this. So if the net thing is in the center, it will attract your more attention. Okay, that's why we are not in the corner. Now that same thing is in the center. So if I put the plus q over here, plus q over here, and the distance between them is a. So between distance we are not considering, we are just need to find out the electric field over here. It's a positive charge, so direction will be away or towards?
Away.
Away.
Okay, away. Electric field because of charge 1 and because of charge 2. So F1, can I write like F1? So you can get that idea. Okay, this is because of this one. And second charge, electric field because of this third vertex side. Electric field away from the source.
Yes,
Away from the source. And we already know the direction of the force and the distance we are going to take along the line of joining. How we write it down in this direction? Why we didn't put like this? So you already know, we put the direction of force and electric field along the line of joining. Line of joining is what? Minimum distance between the two charge, minimum distance between the charge and the point where we need to find out the electric field. Sir, what will be the nature of the third charge? They did not mention that nature of the third charge. They are asking to find out the net electric field at the third side, third vertex. Magnitude of the electric field. Okay, clear everyone? Now can anyone in this classroom can tell me what will be the angle between them? This F1 and oh sorry, E1. This is E1, not F2. Please correct this. It's a E1.
60.
Okay.
60.
Because okay, 60. Many people are saying 60. 60. This is your E1, this is your E2. Okay, please correct this one, not the. And if I need to write down the formula of the E1, which is what? K Q upon A square, and E2 K Q upon A square. Huh? Both the electric field are same. Both the electric field are same. So, So my dear student, both electric field magnitude is same. It means the net electric field will be in between them. Will be in between them. Huh?
Yes.
Yes, sir.
and it's going to make a how much angle if it is in between?
30.
30.
30.
30. The net electric field will be in between them.
Sir,
Hmm.
are we gonna differentiate into sine and cos components?
Yes, we are going to do that. Otherwise, we will not able to find out the net of it.
Sir, can you tell how did it come in 2010?
How it will come? Yes.
I mean, like, how did you
Third-
conclude that electric field is there? Like?
How we get the 30 degree? You are asking like that, right?
No, sir, like I mean, the electric field, the third vertex, like, how did you get that? Like, how did you told that's there? That's what I'm asking.
This is the charge. So there is a region around this charge. Okay. And this is also a charge. There is a region around it. But they are asking us to find out the electric field only in this particular point. So in this point, when we need to apply this formula, we always use a line of joining distance. And along the line of joining, we mark the force direction and the electric field direction. So because of this charge, this is a positive charge, so electric field away from the source. So along the line of joining in the same line direction, okay, the electric field E1, sorry, it's E2, and because of charge 1, electric field away from the source because it's a positive charge, so E1 in this side. And you can see when I write down the formula and to find out the magnitude of the both charge electric field, because distance is same A, I get the kq upon a square, kq upon a square. Both they have a same magnitude. So you already know if both have a same magnitude, the resultant will be in between that, at the center of it.
Yes.
Right. So the total angle between them is 60 degrees. So net electric field will lie in between the 30 degree from the both side. Is it clear? Yes, Vijay, please tell me, is it clear or not? If there is a confusion, please say what is your confusion in this one.
So here, third vertex is taken as the test charge, right? I mean,
We already done that test charge we used to find out the electric field formula. Now we get the formula, so there is no discussion on the test charge. Now there is a only particular point.
okay.
Okay. Now you get this thing over here, and let me show you the another diagram, or we can take a component of this one. Okay, let me show you the another diagram of this one. Okay, this one is too low, so it will not work. This is too low. So I'm going to zoom this part over here, only this part. This part I'm going to zoom it over here. So please pay attention. So when I'm going to take the component, you will get a clarity. Okay, the alignment can be up and down, means it will not exactly look like and both sides are equal. So please cooperate on that one. So this is 30, this is 30. So I consider this magnitude is same, so I consider as a EE. Okay, because their magnitude is same, so I consider both of them as a EE. E1 and E2 I consider as a E because their magnitude is same. Okay, for the sake of cleanness of this diagram. Okay, now I am going to take the component of this electric field. This electric field making angle 30 degree with this axis, so this component will be E cos 30 and perpendicular component will be E sin 30, perpendicular. And when I'm going to take the component of this one, so this the electric field is making a 30 degree with this axis, so this will also E cos 30 and the perpendicular component E sin 30. So now you can see this E sin 30 and E sin 30 are just opposite to each other, so they will cancel out each other. Huh?
Yes, sir.
Their effect will get cancel out with each other. So my dear friend, by this we can say, sir, our net electric field will be equal to what? E cos 30 plus E cos 30, which will be 2E cos 30. 2 into KQ upon A square cos 30 root 3 by 2. So in short, your net electric field will be what? Yes, my dear students. Anyone have any confusion? What we have done? Anyone in this classroom who don't know how to take the component? We can't just take the resultant of two electric field, right? Abdullah, now you can get it now how we are taking it. Dipin, absolutely correct your answer. Abdullah.
Yes, sir.
And in your mind, so many things will come. So what if their magnitude is different? What if they use the different charges at that time? How we can know these electric field are not same? So we cannot know that it will be in the center of it. So something supportive content will be given in that question. 2 means so many unknown things will not be there. At least supportive knowledge will be given so that you will identify where will be the net electric field. Is it clear or not? Obviously, these things will come in your mind. So, in place of this 4Q and 2Q, so these electric field are not equal. Now, this time I cannot find out or identify that electric field will be at the center of in the both electric field. So, something supportive knowledge will be given in the question, by that you will find it out. Okay. So, don't worry about it. Just first understand the approach of this one. Is it clear or not, my dear students?
Yes,
Anyone?
sir, clear.
Okay. Any other student have any kind of confusion?
Yes, sir.
Okay.
So for this type of question, we should use component. That's it.
Yes. Can we move on?
Yes, sir. Okay.
My dear student, charge 1 and charge 2, positive charge, that's why electric field away from the source, electric field away from the source. We write down the formula KQ upon A square, charge value and the distance, charge value and the distance. Now you can see both are same, so I consider as a E. It's equilateral triangle, it's at 60, so this is also going to be 60, that's why we get it. Both electric field magnitude is same, so that's why we said it will be net electric field will be in the at the center of it. Center will be making 30 degree from both sides. Now to find out the net electric field, we take the component of the electric field. We take this as a reference axis. We take this as a reference axis. Always where your logic said, your common sense said, or your gut feeling says, okay, net electric field will be in this direction. Obviously, you get that idea, net electric field will be in this direction. So, take this line as a reference line to take the component. Is it clear or not? Take this reference line to take the component. Always as a base one. 99.99% time, everything will go smoothly. I'm not saying exception. 99.99 times. So, I take this as a base. So, this electric field is making angle 30 degree with this base. So, base component will be cos 1. So, E cos 30. Perpendicular sine 30. Then again, I take the component of this electric field. This electric field making 30 degree with this axis. So, the base component will cos perpendicular sine. And their magnitude is same. E sine 30 is exactly same. They will cancel out each other. So, only these two electric field in this direction. So, net electric field E cos 30 plus E cos 30, 2 cos 30, 2E cos 30, 2 into E KQ upon A square into root 3 by 2. So, 2 get cancelled out, root 3 KQ upon A square. Simple. Anyone have any kind of confusion?
No, sir, no doubt.
Clear now? So, how to identify which reference axis we have to take for the taking the component? This thing also clear now? right? Now, the next topic is what, my dear student, I'm not able to complete that one, but I just give you a glimpse of that one, so you can we can start this topic. Okay, motion of a charged particle. I will repeat everything again in the tomorrow's class. Okay, motion of a charged particle in an electric field. Charged particle in an electric field. Sir, this test charge in the electric field. Motion of a charged particle in an electric field. This charge is in the electric field of this charge. This is going to experience a force. When it is going to experience a force, it will move. Huh?
Yes, sir.
It will move. It will move. When it is going to experience a force, it will move. So, we are going to put the charged particle in three manner. First, we just going to put it and leave it. Put it and leave it. Second, we will throw it into that region. In this scenario, what we have done? We put a charge. We just put it. Put it means initially it was at rest. Then after that it will get an experience of force, then it will start moving. In the second scenario, we were putting it by throwing it. So it means it has some initial velocity. It has already some initial velocity. This time it does not have initial velocity. In second case, it will have some initial velocity. This point is clear or not? Huh?
Yes, sir.
So we get,
Yes, sir.
okay, so we have a initial velocity. It means initial velocity is 0 and force is equal to what? F equal to ma. And I can write like this, A equal to force upon mass.
Yes, sir.
Yes, sir.
If this charged particle is going to move, so tell me what will be the velocity at a particular time t. Sir, we know the thing. V equal to u plus at. It means this charged particle is going to accelerate or deaccelerate. Can anyone answer this one? And we are going to finish the session. Remaining thing we will discuss tomorrow. This charged particle is going to accelerate or deaccelerate?
Accelerate.
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 Okay. Now you have to tell me the electric field direction in this direction. You can see the direction of electric field. It means
Yes.
there is a source in this side which is negative or positive.
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 That's why electric field on this direction away.
Yes, sir.
By the logic you can say that, na, sir, electric field in this direction, it means there is a source which have a positive in nature. So this have a positive in nature and this is a positive charge. So it will experience a force. Repulsion or attraction?
Repulsion.
Repulsion. So it will accelerate.
Yes.
It will accelerate. Am I correct or not?
Yes, sir.
Easy, na? So it will accelerate. So now you are going to use the initial velocity 0 plus F upon m into t. This is your velocity. And you can put the force value into that formula. Force value. Force is what? K, Q, oh, not KQ. I will discuss it in tomorrow class. Okay. Force value we will discuss in tomorrow class. I will repeat each and everything again. It's not complete discussion. We will discuss it entirely again in tomorrow's class. Just understand one thing, how to identify the charge is going to accelerate or deaccelerate. Okay. This was the main agenda of this topic. Remaining thing from the scratch we are going to cover this again. Okay. And Vijay, please do not miss out the tomorrow's class. Otherwise, if you and so many students also there, if someone is going to miss out, then this topic is really tiny. So maybe you will not able to cover it or you will not see in your school also properly. One thing also there, when we are going to finish that, we will start continuous bodies, finding out the electric field from the continuous bodies, just like we find out the moment of inertia of a rod, of a ring, of a disc. Okay, I already discussed in the bridge class. Those who didn't join the bridge classes, you don't need to worry about it. I will repeat each and everything again. Okay. So this is the thing, my dear friends. We will meet again in the tomorrow's class. I know little bit discussion we had today, and that is the class. This is how we are going to run our class, by your doubts. Okay, we have to appreciate each and everyone's doubt. Otherwise, people stop asking their doubts and they will remain at the same level. Okay.
Sir,
Yes, Vijay.
sir, so if two charges are there, okay, F is equal to K, Q1, Q2 by R square. So basically, F is a force experienced by the two charges and the force between them, right?
Force experience on each other.
Okay.
This is a charge, and this is a charge 2, charge 2, charge 1. So they are going to repel each other.
Yes, sir.
So on this charge 1, force on 1 because of 2. Force on charge 2 because of charge 1. So they are going to apply the force on each other, opposite direction, but they will have a same magnitude. They will have a same magnitude but different direction. So they are going to apply the force with the same amount on each other. Clear?
Yes, sir.
Okay.
So, DPPs will be revising, sir, discussing tomorrow before the class starts, right?
You can tell me, you can send your doubts to me. Okay, tomorrow we will discuss the next topic. Okay, in DPP we also mention the solution. So still, if you find any kind of difficulty, you can reach out to me directly. Okay, the batch manager Shweta ma'am, you can reach out to Shweta ma'am. She will provide my number to you. You can directly reach out to me. Okay.
Yes, sir.
And this is for every student. Whenever you are discussing anything related to the physics, covering anything, and if you find any kind of difficulty at any time, you just need to send me your doubt, but I will reply you back when I wake up. Okay. Many students are the owl, so they study at late night. So you have to send me immediately at that time, because I know till morning you forget that what kind of doubt you had last night. Immediately you have to send me, but I will reply you back when I wake up. Okay. So please do not mind if I sleep too late. Okay. Bye everyone. Good night everyone. Bye bye. Bye bye everyone. Bye bye.
Thank you, sir.
Welcome. Bye bye. Bye bye everyone.
Thank you, sir. Bye, sir.
Bye,
Good night,
sir.
sir.
Welcome. Welcome. Good night. Good night. Bye bye everyone.
Bye. Thank you.
Allah Hafiz.